What's up, guys? Let's keep plugging along here through our half-life equations. And for this next one, let's get medical. Nice. All right, so we're talking about a patient who was given a 20 milligram dose of iodine 131. It's a common isotope used in medicine. It can be used as a tracer in the body to see where certain things are flowing, blood, oxygen, etc. It can also be used to treat thyroid cancer. The way it decays is very dangerous to the thyroid, but if it's a cancerous thyroid, it can kill the tumor, which is going to attract more of the isotope. So anyway, here's a little bit of a real world application. So what do we know from our question stem? Well, we know that the patient was given 20 milligrams, so that's our initial amount of iodine 131. We know that the half-life is 8 days, and we're being asked how much is left after 40 days. Okay, so another pretty straightforward question where we're being asked to solve for the amount after a certain amount of time. So again, we're being asked to solve for A in our equation. We're given A naught as 20 milligrams. And again, we're given the total amount of time along with the length of one half-life. So we're going to solve for N that way. So let's do that first. Okay, so we know one half-life is 8 days, and we know that it was in there for 40 days. So how many times does 8 go into 40? Well, it goes in 5 times. Okay, so 5 are the number of half-lives. So let's go ahead and plug that right on into our equation here. So we have A is equal to our initial value, which is 20 milligrams. And that is going to be multiplied by 1/2 raised to the 5th power. Okay, so 1/2 raised to the 5th power is going to be going to equal 0.03125. Okay, that's the fraction. If we did it out the long way, it'd be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So again, we're working with 1/32, which we've seen a couple times before. So we have 1/32 of 20 milligrams of our initial value, which is 20 milligrams. That's how much is going to be left, 1/32 of that. So let's do the math on that, multiply by the decimal, or you could divide it by 32, whichever way makes more sense to you, I suppose. Okay, so times 20. So this is going to end up equaling 0.625 milligrams. That's our value we started, or our value that we have after this amount of time. However, once again, when we look at this, how many significant figures do we have here? Just the one, because we're trailing 0 with no decimal. So we're rounding to one significant figure. And so we're rounding to this one. There's a 2 here, so it stays the same. So 0.6 milligrams. That's how much is left in the patient's body after 8 days. How much of the isotope stays. Okay, and I'm going to do a double attack here and do the second one in this video as well. Okay, so Protactinum 226 has a half-life of 2 minutes. If you start with a 160 grams sample, how long will it take to have 10 grams remaining? Okay, so a little bit different here. We're told how long the half-life is. Okay, we're told that half-life is 2 minutes. We're told our starting amount, and we are told our ending amount. And we're asked how long is it going to take to get to that ending amount. So a few different ways you can do this. If you want to go the advanced or more advanced math route, you can do it using some logarithm and finding the exponent that would be on the half to represent the number of half-lives, and then multiply by the length of one half-life. If you want to try and do it that way, go for it. I'm not going to do that. I'm going to keep it a little bit simpler, and I think that it's easier to solve this equation with it being a little more simpler, at least with these numbers that I gave you here. So first of all, let's find out what fraction of the sample is going to be remaining. So if I do 10 divided by 160 to see how much I have left, that is 1 over 16, right? Because the zeros just cancel. 1 over 16. Okay, and 1/16 you might already know, but let's do it out. It's going to be 1 half-life times 1 half-life times 1 half-life. 2 times 2 is 4 times 2 is 8 times another half-life is 1/16. So we underwent 1, 2, 3, 4 half-lives. So that means that your number of half-lives is 4. Okay? So we know it takes 4 minutes to get down to 10 grams. It takes 4 half-lives to get down to 10 grams from 160. So 4 half-lives, each of which being 2 minutes. 2 times 4 is 8. So the total time equals 8 minutes. Okay, so there's another example kind of coming at it from a different angle. Just kind of understanding what we're looking for, what a half-life is, etc. So these three equations, these two first ones are pretty straightforward, solving for how much is left after a certain amount of time, the most common to solve. And then this one kind of makes you think of it a different way. The other examples we did in class are also good questions for making sure that you're understanding what's going on in these half-life calculations. Okay, so in the next video I'll attack this big question, which I think really touches on a lot of stuff. And I'll do a quick fusion and fission video later on just to cover that